Hello students, welcome to the channel. In our series Target 750 Plus, we look at advanced questions from different math topics that you're likely to see on the SAT and ECT. Today we look at statistics. So let's begin. Question 1. Given the set of n numbers, n greater than 1, of which 1 is 1 minus 1 by n and all the others are 1, the arithmetic mean of the n numbers is. So first we need to understand what arithmetic mean is. Arithmetic mean is the sum of all data points divided by the number of data points, right? That's how we define an arithmetic mean. So there are n numbers, of which one number is 1 minus 1 by n, and all the other numbers are 1. So how many ones will there be? There would have to be n minus 1 ones, because out of the n numbers, one number is 1 minus 1 by n. So how many numbers remain? N minus 1. And all of those n minus 1 numbers are 1. So what will be the sum of these numbers? It would be 1 minus 1 by n plus 1 plus 1 plus 1 up to n minus 1 times. So that would be 1 minus 1 by n plus, if you keep adding 1 n minus 1 times, then that total will simply be n minus 1. Plus 1 and negative 1 cancels, so we get n minus 1 by n. So the sum of all data points is n minus 1 by n, and the number of data points is n. We can write this as n by n minus 1 by n by n, which is 1 minus 1 by n squared, option D. So this is how you can find the arithmetic mean of a data set. Okay, let's go to the next question. Question 2. A data set for a class of 25 sixth graders has their ages listed as the integer values of either 10 or 11 years. The median age in the data set is 0.36 years greater than the mean. How many 10-year-olds are in the class? So let's say that we know that there are 25 kids and they are either 10 years or 11-year-olds. So let's say the number of 10-year-olds is X. So the number of 11-year-olds in this class would be 25 minus X, because the total number is 25. So what will be the mean? Let's first find the mean. The mean would be the total value, the total sum of all ages. 1 second. The total sum of all ages divided by 25. So that would be 10 times X plus 11 times 25 minus X divided by 25. That's the total mean, right, of all the ages. And the median age in the data set. How do we find the median age? Now you know that if there are 25 values, right, and there are a bunch of 10 or 11, we don't know which are 10s, which are 11s, then the 13th value will be the median, right? Because 25 is an odd number, so the median will be 25 plus 1 by 2, the 13th value. Now think about it. If the median age is greater than the mean, can the median age be 10? It can't be, right? Because if there are a number of 10 age students and there are a number of 11 age students, and the median age could be 10 or 11, the 13th value could be 10 or 11. Now, Obviously, the mean would be something that includes both, includes part of the 10-year-olds and the 11-year-olds. So for the median to be greater than the mean would have to be 11, right? Because the mean would also be influenced by the 10-year-old. So the mean could be less in that case. So by that logic, the median has to be 11. It can't be 10, right? So then we find that the median is 0.36 years greater than the mean. So 11 is 10x plus 25 minus x into 11 by 25 plus 0.36. That's the equation. Now, how can we solve this? Let's just multiply the whole equation by 25. So I'll write it on top. One second. Yeah, so if I multiply 25 by 11, I get 250. So that's 275. 10x plus 25 minus x into 11 stays the same. And 25 into 0.36. This is problem solving and data analysis. So you can plug this into the calculator. What would 25 into 0.36 be? That would be 9. So that's just 9. So what is 275 minus 9? That's 266. 10x plus 25 into 11, which is 275 minus 11x. So x becomes 9, right? So we get x is 9. So when we started, we took x as the number of 10-year-olds in the class. And so that's 9, option C. So the number of 10-year-olds would be 9, and the number of 11-year-olds would be 16, right? And so you can see that the 13th value is indeed 11, which is what we had assumed when we solved this question. Question 3. The following table shows the amount of rain that fell during a 15-day period in 2008. What is the mode of the amount of rainfall in inches over these 15 days? So the mode is the most common element of the data set. So if I were to write the data set as a list, then I have 0 occurring 6 times. There was no rain on 6 days. I have 1 occurring 4 times. I have 2 occurring 3 times. I have 3 once and I have 4 once, right? So I can see that the mode would definitely be 0 because that's the data set that's most common. So the answer is option A. Question 4. The table below shows the number of houses sold per week for the month of July by 3 real estate agents, Pete, Dylan, and Smith. So these are the weeks of July. And in week 1, Pete sold 4 houses, Dylan sold 9, and Smith sold 7. So the rows tell you the total number of houses sold in a week, and the columns tell you the total number of houses sold by an agent. So over the entire month of July, the 3 of them sold a total of 72 houses. What is the difference between the median number of houses sold per week by Dylan and the median number of houses sold per week by Pete? Okay, so Pete sold 4, 6, 10, and 4. These were the 4 values that he sold. So if I put them in ascending order, I get 4, 4, 6, and 10. So the median, there are 4 values. So the median would be the average of 4 and 6, which is 5. So the median for Pete is 5. What is the median for Dylan? For Dylan, the values were 9, 3, 10, and 2. When I put them in ascending order, I get 2, 3, 9, and 10. So here again, there are 4 values. So the median would be the average of 3 and 9, which is 6. So the difference between Dylan's median and Pete's median is 1. 6 minus 5. Okay. Next question. We have the same data of these 3 real estate agents. And the question is, which of the following represents the correct order of the standard deviation for the houses per week sold by Pete, Dylan, and Smith? So the standard deviation, right? Remember that on the SAT, we don't have to use the standard deviation formula. We don't have the time to use the formula. We have to look at the data and make an educated guess. So there is Pete, there is Dylan, and there is Smith. So Pete has 4, 6, 10, and 4. Let me actually write it in ascending order so that we can analyze it better. So for Pete, it is 4, 4, 6, 10. For Dylan, it is 2, 3, 9, 10. And for Smith, it is 4, 5, 7, and 8. Now, let's say Smith's average is 6. Let's say his mean is 6. So the spread of his data is 4 and 5 on the left and 7 and 8 on the right. So the spread is pretty compact. It's not that great. It's not spread out too much, right? Compare it to Dylan. So for Dylan, let's say the mean is again 6. I don't know the exact mean, I'm assuming. But here, the spread is much greater than in the case of Smith. I'm going up to 10 on the higher side and going down to 2 on the lower side. So I know that the standard deviation for Smith is definitely greater than the standard deviation for Dylan. The standard deviation for Dylan is definitely greater than the standard deviation for Smith. What about Pete? Now, Pete, I think his mean would be probably 5. And Pete is showing some deviation on the right, going up to 10, right? Definitely. But on the left, it's only up to 4. So there is some spread, but it is not as great as Dylan's. But it is also not as less as Smith's. Smith's data is the most compact. So I would put Pete in the middle, right? I would put Dylan as the one with the highest deviation, and I would put Smith as the one with the lowest deviation, because the data for Smith is the most compact. So the answer would be the deviation for Smith's data is less than the deviation for Pete's data is less than the deviation for Dylan's data. Option D. So those were 5 advanced problems on statistics. If you found these tough or if you were unable to solve these, make sure you revise your basics and then approach them. Hope the video was useful. If it was, hit like and subscribe to the channel. I'll see you guys in a new video soon. Take care. Bye-bye.